Hello guys, my project is building an intrusion detection system using machine learning and software defined networking. First of all, I made an important changes to the SDN environment setup for this project. Initially, I planned to use traditional SDN tools like RYU, OpenFlow and Mininet. However, these tools cause compatibility issues and errors on modern Linux machines due to outdated software versions. For SDN-based IDS setup, we moved away from traditional SDN environment like RYO, OpenFlow, and Mininet. These tools, while powerful, often cause compatibility issues and errors on modern Linux systems due to outdated softwares. To ensure a smoother, more adaptable setup, we built a custom SDN-like environment using two virtual machines in Oracle VirtualBox. A Kali Linux machine simulating the attacker and Ubuntu machine act as both victims and IDS host. We deploy SCAPI on the Ubuntu VM to capture and analyze live network traffic in real time. This approach allows us to detect various types of attack like DDoS, IP spoofing, and port scan while avoid the limitation of older SDN frameworks. These are changes I made to my project and now the model for my project is complete. So for my intrusion detection system IDS project, I'm working with the network traffic data set that has 42 features and 25,000 entries, including things like protocol type, service, and byte count. The first thing I the first thing I did was check the data for any missing values, and fortunately everything came black came came back clean, no missing data at all. I also checked for duplicate rows and there were none, so the data is good the data is in good shape. Next I took a look at how the classes in the data set are distributed. I visualize in with the count plot to see how balanced the normal and anomaly classes are. Turns out there are 13,000 samples of normal and 11,000 of anomaly, which is pretty well balanced. To prepare the data for training, I use label encoder to convert categorical column like protocol type, service, and flag into numbers that the model can work with. I also decide to drop the non-outbound CMDS column because it didn't seem relevant for the model. When it comes to training the model, I separated the features X and the target Y. So the features X train, so the features X are all the column expect class and the target in the class column which will be used to train the model. I have I have already created the model and tested two different models, logistic regression and decision tree. I compared their performance by looking at their accuracy score on both the training and test sets. I have put the result in the table, make it easier to compare the model and see which one performed better for this ideas task. So to sum up, the data is all clean, pre-processed, and the models are ready to go. Now I'm moving ahead with evaluating the models and finalizing the next steps. and I found a good data set from the internet for my project. So I came across really useful traffic data set with over 22,500 rows and 41 columns. It has variety of features like the duration of each connection, the protocol type, the service being used, and the amount of transferred, both send and receive. For example, if we look at the protocol type, we see that most of the traffic is using TCP, which is around 84%, followed by UDP at 12%. When we dive into the service column, we see that HTTP is most common service, making up 35% of the data, while private account for about 25%. Another interesting part is SRC bytes and DST bytes, which represent how much data is being transferred. The values vary quite a bit, showing us how much data different type of traffic generate. There are also a lot of zeros in the dataset which could represent normal values or the absence of certain activities. Depending on the context, this gives us an idea of the traffic pattern and behaviors in the dataset. So this dataset is looking pretty solid for training and testing intrusion detection system, and I will be using it to build and refine my model. And this is the progress video for my project. Thank you.